Okay, so we're going to start with long division. So we remember from long division, we're going to set it up like this, where underneath our division house, we have a dividend of 8. Okay, on the outside of it, we have our divisor, and when we divide, we put the answer on top. That's our quotient. Okay, so we're going to use the same algorithm that we use to divide with regular numbers for polynomials. Okay, so we have here, then we'll talk about synthetic division. Synthetic division can only be used if the divisor is in the form x plus or minus c, where c is any constant. Long division you can do with both. So we're going to start with an easy one for long division. So here we have x cubed plus 6x squared plus 10 divided by x minus 2. So for long division, we're going to order the dividend from greatest to least by exponent, filling in any missing exponents with 0. So that means I want to go in my exponents descending order. So I've got an x cubed. I have a plus 6x squared. I am missing an x to the first, so I'm going to fill that in with a 0, x to the first. And then I have a plus 10 as my constant. Okay, that's going to go in my division house as my dividend. Then I'm going to place the divisor, typo right there, x minus 2 on the outside. Oh, okay. I changed it slightly. Okay, so when we're doing our regular division, what we do is this first term here divided by this first term here. Okay, so that's what we're going to be doing with our polynomials. So we're going to take the first term of the dividend, which is x cubed, and we're going to divide that by the first term of the divisor, which is x. So we do x cubed divided by x, which gives us x squared. We're going to take that and we're going to put it on top of our division bar. That's our quotient. Okay, then when you're doing long division, what you typically do is then you take the quotient, multiply it by the divisor. That's step 4. So we're going to take the quotient, multiply it by the divisor, which means I'm going to do x squared times x. So basically I'm distributing, which that's going to give us x cubed. I'm going to put it underneath the dividend. And then x squared times negative 2 will give us a negative 2 x squared. Step 5, subtract. Okay, so I subtract. When you subtract, basically that means you are changing all signs. Okay, so this becomes minus, this becomes plus. Change all signs. Okay, then combine. So x cubed minus x cubed is 0. 6x squared plus 2x squared gives us a positive 8x squared. Then we bring down the next term, 0x. Okay, then step 6, we repeat steps 3 to 5 until we've done all of our division. Okay, so step 3 again. We've got first term divided by first term. This time our first term is now this 8x squared. So we're going to do 8x squared divided by my first term, x. So I'm always dividing by that first term, x, when I do this. That's going to give me an 8x. I'm going to take the 8x and I'm going to place it up here. And I'm going to put a plus sign in front of it because it's positive. Okay, then step 4, I'm going to multiply the divisor and the quotient. So I'm going to do 8x times x minus 2. So 8x times x gives me an 8x squared. 8x times negative 2 gives me a negative 16x. Then step 5, subtract or change all the signs. So this becomes minus, this becomes plus. 8x squared minus 8x squared is 0. Okay, 0x plus 16x plus 16x. And I bring down my last term, plus 10. Then I go back up to step 3 again. So first term is now 16x. So I'll do 16x divided by my first term, x. And that's going to give me 16. So I place the plus 16 up top as my quotient. Then step 4, multiply the divisor and the quotient. So I'm going to do 16 times x. That will give me a 16x. And then 16 times negative 2, negative 32. Okay, then I'm going to change all signs. So minus, plus. 16x minus 16x gives me 0. 10 plus 32 gives me 42. Now I'm done there because I can't do 42 divided by x. Okay, so this is my remainder. So in elementary school, you always wrote R42, right? Well, now you're just going to write it like this. So you're going to write it as a plus, and then you're going to write your remainder over your divisor, so over x minus 2. So my answer is right here. So it's x squared plus 8x plus 16 plus 42 over x minus 2. All right, so it seems new, but it is still the same process that you use for regular division. I think you just probably never thought about what the actual steps were written out before. So you've already got it, so just a few practice runs and you should be okay with it. Let's do one more example. All right, so first step for example 2, I'm going to look at my polynomial here and I'm going to look at the exponents, make sure I'm in descending order. So 4, 3, 2, 1, and then my constant. So there I'm in descending order. I don't need to fill in any blanks. So I'm just going to rewrite this so I can put it in my division house. And then the divisor is going to be 2x minus 2. That's going to go on the outside. All right, and then I'm going to start with step 3, first term divided by first term. So I'm going to do those off over to the left. So 6x to the 4th is the first term, and then that's going to be divided by 2x. So we'll be dividing by 2x each first term here. That's going to give me, let's see, 6 divided by 2 is 3, and then x to the 4 minus 1 would be x cubed. So I'm going to put this 3x cubed up on top as my quotient. Then I'm going to multiply. So 3x cubed times 2x gives me a 6x to the 4th. 3x cubed times negative 2 will give me a negative 6x cubed. Okay, then change all my signs. So this becomes minus, this becomes plus. That's one thing. Just make sure you always do that step because that's one that sometimes people forget. So always change those signs. Then these cancel out. You get 0. And negative 14 plus 6 is going to give me a negative 8x cubed. No, you can put it over all the way to the left or over to the right. That's up to you. Okay, bring down the plus 8x squared. And then first term divided by first term again. So now your first term is a negative 8x cubed, and your first term 2x. So there you have negative 8 divided by 2 is negative 4. And x cubed divided by x is going to be 3 minus 1, x squared. So put your negative 4, x squared, as your quotient. Then multiply. So negative 4x squared times 2x. Negative 4 times 2 will give me a negative 8. And then x cubed. And then negative 4 times negative 2 will give me a positive 8. And then that will be x squared. Then change the signs. So this will become plus. This will now become minus. And you get 0 plus 0, x squared. That's okay. Bring down your next term. Okay, the plus 14x. And then go back to step 3. 0x squared divided by 2x. 0. Okay, put the 0 on top. And you can put 0x if you'd like. 0x. Okay, then multiply. 0x times 2x is going to give me a 0, x squared. 0x times negative 2 will give me a 0, x. Change the signs. Okay, the 0x squareds will cancel. And 14x minus 0x stays as 14x. All right, then next we have, bring down the next term. So next term is a minus 14. And then first term divided by first term. So your first term here is 14x. And we're dividing by 2x. So there the x's will cancel, and 14 divided by 2 will give you 7. So put plus 7 up top, and then distribute. 7 times 2x gives me 14x. 7 times negative 2, negative 14. Change your signs. And I love it when this happens. Everything cancels, remainder of 0. Okay, so then your final answer is what you've got up top there. You can box that, or you can rewrite it as, let's see, 3x cubed minus 4x squared. Do I need to write 0x? No. Am I going to mark you wrong if you do? No. Will my math lab mark you wrong if you do? Yes. So 3x cubed minus 4x squared plus 7. Now, how would I want to check my work to make sure I did this correctly? Yeah, the opposite of divide. So multiply. So multiply your answer by the 2x minus 2. You should get your divisor. Always forget. Dividend. You should get your dividend. Okay, if you want to do that. It doesn't work as well when you have a remainder. All right, synthetic division. Do you guys remember synthetic division from intermediate algebra? Perhaps? Synthetic division is pretty easy. It's just knowing the process of doing it. So anytime you have just a singular x plus or minus a number, you'll want to do synthetic division because it's easier than long division. Long division's reserved for this, when you have a number in front of x. Okay. So synthetic division, the first step is the same as the first step for long division. Make sure you have descending order here. So I've got a 2x to the 5, so 4, 3, 2. I'm missing an x. So this is 2x to the 5th, 2x to the 4th, 5x cubed minus 2x squared plus 0x to the 1st plus 1. You got to fill in that missing value if there are any descending. So then 5, 4, 3, 2, 1, then your constant on your exponents. And then for synthetic division, you're only going to pull the coefficients for each one. So you're going to pull the coefficient 2, then positive 2, positive 5, negative 2, 0, and 1. You're going to line them up like that. So fill in the missing descending order. So same steps. So write it out over here, write it over here. Okay, missing x's. Okay, then line up coefficients. Okay, then you're going to do your division pants. Okay, which I call them pants because they're like an upside down division bar, so they're on the bottom. So pants are on the bottom, so I say division pants. Okay. Inside the division pants, you're going to take the opposite value of this because you're going like this. X plus 2 equals 0. So subtract 2, negative 2. So you're going to put a negative 2 in your division pants. I'm sorry, I didn't hear you. It says division pants. It says line up coefficients. Okay, and then you're going to do this process here. Okay, so you're going to do this and you're going to keep repeating it. You're going to bring down the first term, and then you're going to multiply, okay, what you brought down by the divisor, term in your division pants, and you're going to put that answer right here. So I'm going to say multiply. It will let me. There we go. So 2 times negative 2, negative 4. Then you're going to add 2 minus 4, negative 2, or 2 plus negative 4. So the process is multiply, add, and then you just keep repeating that until you get to the end. So then again, you multiply, negative 2 times negative 2 gives you positive 4, put it right here, then bring down 5 plus 4, 9. Repeat again, 9 times negative 2, so you're always multiplying by this negative 2 here. Negative 18, negative 2 minus 18, negative 20. Repeat, negative 20 times negative 2, positive 40. 0 plus 40, 40. 40 times negative 2, negative 80. 40, yep. And then 1 minus 80, negative 79. Okay, so then you're going to take your numbers, and your answer is going to be 1 degree down from where you started. So answer is 1 degree less than the dividend. Okay, which means I started with an x to the 5th, so I'm just going to go 1 degree down. So I'm going to start here, 2 x to the 4th, then I have a minus 2 x cubed plus 9 x squared minus 20 x plus 40, and then I have this remainder of negative 79. So minus 79 over x plus 2. Yeah. So it's just remembering the process for this, but once you do, it's pretty easy to get the hang of. And then also remembering to look for the zeros. That's one thing that I'll see a common mistake. So make sure, check that there's nothing missing. So example 4, I've got x to the 4th. So 4, 3, 2, 1, constant. I'm good. So I don't have to fill in any missing zeros. So I'm going to line up the coefficients. Here I've got a, let's see, 3, negative 59, negative 10, negative 75. And then what am I putting in my division pants? Negative 5. Let the opposite sign here. Then I do a positive 5. Yeah, because remember, you're saying, okay, I'm going to set it equal to 0, and I'm going to solve, is that an x value? So here I bring down 3. Then I'm going to do 3 times negative 5. And I use arrows. Sometimes people don't use the arrows. So it's up to you. Okay, so 3 times negative 5, negative 15. 3 minus 15 gives me a negative 12. Then negative 12 times negative 5 is going to give me positive 60. Negative 59 plus 60 should give me a positive 1. 1 times negative 5 will give me a negative 5. Negative 10 minus 5, negative 15. And negative 15 times negative 5, is that positive 75? Yeah, and then 0. So remainder of 0 there. Then you go 1 degree down. So the dividend was 3x to the 4th. So you're going to start with an x cubed. So 3x cubed minus 12x squared plus 1x, so just x, minus 15. All right, example 5 is a little bit different, and it says solve the equation x to the 4th plus 2x cubed minus x squared minus 15x plus 2, given that 2 is a 0 of the function. So we're not going to actually solve this just yet. We're going to do that in the next section, but we are just going to divide. Okay, so we're going to divide. But division is going to be the process of solving, so it's going to start the process. So if you're given that 2 is a 0 of the function, all they're saying is this, x equals 2. So you're going to divide the same way you do normally. You just don't have to change any signs because they're already giving you the x value. So remember up here, I did x plus 5 equals 0, and then I got x equals negative 5. So I put the negative 5 in there. So there, they're just giving it to you as the equals instead of as x minus 2 would have been that function. Okay, so it's just giving you the answer already. I'm sorry? Yes. Okay, so do we have any missing zeros here? Or any x's that are missing? No. All right, so let's line this up. You've got a 1 x to the 4th, 2x cubed, negative 1x squared, negative 15x, and a positive 2. Inside your division pants, just a positive 2. Okay, so here I bring down my 1. Multiply 1 times 2 would give me 2. Add 2 plus 2 would give me 4. Multiply 4 times 2 gives me 8. Negative 1 plus 8 gives me 7. 7 times 2 will give me a positive 14. Negative 15 plus 14 will give me negative 1. Negative 1 times 2, negative 2, and then 0. Okay, so because it tells me it's a 0, that means I should get a remainder of 0. And then 1 degree down would be a 1x cubed plus 4x squared plus 7x minus 1. And then as I go to solve, then I can further start from there and further solve the problem, which we will do in the next section. We just have to look at a few other things. All right, so the remainder theorem is that if p of x is a polynomial function and c is a constant, if the polynomial is divided by x minus c, then the remainder is p of c. So what does that mean? So from the first page, we had this example here, x cubed plus 6x plus 10 divided by x minus 2. That was, I think, example 1. Yeah. The remainder here was 42. Okay, so in this example, the remainder was 42. So what is p of 2? So this theory tells you, okay, you can quickly test to see if there's going to be a remainder. If I plug 2 into the function, 2 cubed plus 6 times 2 squared plus 10. So 2 cubed would give me 8 plus 6 times 4 would give me 24 plus 10, 42. So when I plug p of 2 in, I'm actually going to get 42. So that's your remainder theorem. Your remainder will be what you get when you plug the function in. Or for example, I think this was the very last example we just did. No, the one right before that, example 4, we had a remainder of 0. So if I plug negative 5, this should say negative 5. If I plug negative 5 into the function, I should get 0. So 3 times negative 5 to the 4th plus 3 times negative 5 cubed minus 59 times negative 5 squared minus 10 times negative 5 minus 75. All right, so let's check those. So negative 5 to the 4th is 625 times 3. That gives us 1875. Negative 5 cubed is going to be negative 125 times 3. Negative 375. Negative 5 squared is 25, so negative 59 times 25 is negative 1475. Negative 10 times negative 5 is positive 50 minus 75. So let's see what we get here. So 1875 minus 375 minus 1475 plus 50 minus 75, and I get 0. So the remainder theorem tells us that if we divide and get 0, if I plug that number in, then I should also get 0 when I work the equation out. And then the factor theorem is the same thing. So if I plug the value of x in, or the constant, and get 0, then that means x minus that constant is going to be a factor of the function. Okay, so if p of negative 5, I get 0, then x minus negative 5, in other words, x plus 5, is a factor of the function. Okay, so for example, in the first page, is x minus 2 a factor of x cubed plus 6x plus 10? No. The reason why is because when I did p of 2, I got 42. Okay, so in the other example, is x plus 5 a factor of this function here? Yes. And the reason why is because p of negative 5 is 0. So it's a factor if P of C equals 0. And that's what the factor theorem is telling us, and the remainder theorem. All right.